Hey, Assalamualaikum warahmatullahi wabarakatuh. And hi everyone, good day. If we look into the previous video that I shared about GCMS, okay, one of it is a determination of concentration of a compound using the GCMS. We also received some requests and inquiry about how to identify the compound and make a full report of a percentage of uh, composition of extract or any sample, the individual compound that can be detected by the GCMS. So for today, I would like to share about this procedure and the how we can make an identification of compounds detected using the GCMS. And in this case, we are going to share about the sample being extracted from oil sample. And from there, we can make a full report so that you can make it and attach them in your result and discussion if you want to publish the result using the GCMS. So let's see if we remember about this one. So previously we use enhanced data analysis software. So this software was coming from the Agilent software. So when we purchase any GCMS, okay, in this case we have GCMS quadruple. So together with that, we will receive this software so that we can operate the GCMS. Together with that, we can analyze the result from there. Okay. So for example, I would like to open one file that I have collected or retrieved using the GCMS. I want to load data. So this data, for example, I have one sample, which is an oil that has been extracted with from blood. So we will like to identify how what other compounds can be detected in blood. So for example, so and I hit OK. Okay, so I will get this result. And for your information in GCMS, there are two types of data which we can see here. If you click here, select signal to load. So in this case, when we analyze the data, the sample, we set it to be recorded in two type of data. The first one is mass data. The second one is SIM data. So the scan mass data is the scan data mode, which is it will scan any kind of peak or compound that being detected by the GCMS. Okay? But if you have setting up the data SIM mode, SIM means selected IO monitoring. So you will get a specific compound where usually we need to introduce the molecular weight of the particular compound of interest. Okay, so in this case, we recorded both of scan mode and SIM mode data. So that's why you can see here, okay, we will get two type of data. So the top one is the scan mode. So any compound that being detected will be appeared and will be displayed. And for the SIM mode, since this is compound that we have selected are the 37 fatty acid methyl ester. So only 37 fatty acid methyl ester will be detected. Okay. So in this case, usually if we want to identify the compound that being detected, um, in a general or in a generic approach, so we just open the as scan mode data. Okay, so you go back to select signal, choose data.ms, and then we can click OK. So you will get this data. Okay, so in this case, we see that there's a lot of peak there, but we want to know how much peak that can be detected and how much compound or how many compound that can be identified. So we can go to start with integration of the peaks. Yeah, so we go to chromatogram, select integrator first, and then we need to choose scan station integrator. So in this case, if you are looking to identify the compound and compare the mass spec of each compound to the library. So in this case, we have the NIST library here. So we need to choose a CAM station integrator. Okay, so and then I click OK. But this is part of choosing integrator first. Now we want to integrate. So click again chromatogram and then click integrate. So you will see they identified 359 peaks. Yeah. Um, so when we identify these peaks, we can look into this result by clicking spectrum, select library, you have to make sure the library that you have is NIST library. So in this case, is it the 2011 version, the one that we have? If not, you have to click browse and then choose the library that you have purchased and installed. So in this case, this GCMS only attached with the NIST 11. So we click NIST 11 and then click OK. And then you can click Spectrum and then click Library Search Report. Okay. So when you click Library Search Report and then I choose Screen, so the result will only be displayed in the screen only. If we click Printer, it will print your result. Okay. So this is the result that we received. So you can see here it's very lengthy result, but we can and a little bit uh, mixed up. So we want to make it a clearer version. So you can click all, and then we can reduce the font into 8. So you can see we have a better version of result. So you can see here the way that we identify whether the compound is really having a match to the library, the NIST 11 library. You can see at the qual column here. So qual mean qualitative. So if you have 64, that indicate the peak at the retention time of 0.347 is matching at 64% to the max spectra of this tributyl dimethicillate ester benzene acetic acid. So this qualitative indication indicate that how much the matching of the peak in the sample against the library, the NIST 11 library that we have. Okay, so this is another way of doing it. But we have also another version where we can, instead of using the WordPad result, we can also make it to appear in term or in the form of Microsoft Excel. Okay, so let's see how to do it. So you can go to click Export Report. Since we are now only find the matching against the library search report, so you can click Library Search Result Report to XLS. XLS means it will convert the results from the WordPad into the Excel. So if you click here, then you will get this is the Excel results. Okay, so you can see here from those compound that being detected, they can provide, for example, the compound number one at retention time 14.389, for example. So they provide that 20 hit number. 20 hit number means 20 potential compound that can be identified where the mass spec from each of these compound is matching the um, mass spec library in the NIST. But you can see even though it match, but the percentage of matching is very low, 5, so on and so forth. Okay, so this is the Excel result. So usually for us to make a better report using this Excel is better instead of using the WordPad. So we can rearrange this data by clicking only the retention time, rearrange the result and using the retention time. So for example, I would like to highlight the retention time. Okay, okay, for example here. So I will go to this sorting part from the smallest to largest and then click expand the selection. So you get here. So this is how the result looks like. So you can remove the rest of the result which is not being selected, not be selected as the top candidate for the particular compound retention time. Okay, you can click delete. So only this compound will be accepted. Okay, so from here, what we need to identify is, okay, you can see here the qualitative amount as well is not that good. It's very low, but it's okay. I just want to show to you how we can make a report in terms of percentage area. Okay, so you can see here, there is a result here. Okay, we can see the compound number, retention time, scan number, area, baseline height, or absolute height, and so on and so forth. Okay, so this one, The question that's coming to our YouTube is about how we can make a report of percentage area, percentage composition of the individual compound that being detected here. So what we can do, it is based on this area column. So you need to click a new, insert a new column, okay, and then you need to make a title relative uh, area in terms of percentage. Okay, so from here, what you can do, you can sum up the whole compound that you have. Go to sum all those compounds area. Okay, from here, and then you can make a percentage by using this formula, area times 100 divide the sum. Oh, sorry, should be this one. By we put no, just divide by. All right, then you click enter, so you get a percentage. But you have to make sure now we want to retain this sum value. So at the cell, you have to put the dollar sign before and after of the alphabet, so that when you drag down the results, you can get the total percentage. And then you can see here it will not move. Yeah, the D37 will not move, will stay, even though you go to a lower compound number. Okay. Okay, and then to confirm this one, you have to make sure when we have percentage area, so if we sum up this relative area, you will get 100%. So for example, I can drag this one, so you can get 100%. That's indicate the total relative area. When we sum up each of the compound that being detected here, we can get 100%. Okay, so this is how we make a report of relative area or composition of the compound based on the relative area in the unit of percentage. Another better, it's not a better, an improvement way of displaying the result is by choosing the numbers of decimal points. So in this case, I would like to have just 2 decimal point, and then from here I can say that, for example, I got this compound, yeah, this ketone, for example. So the total area is 42.47 compound, followed by this one benzodiazole, so on and so forth, yeah, 14.83, and another one is penantrol, yeah, so on and so forth. So this is how we can uh, telling the reader of about our samples, which compound are the dominant one in the samples. Okay, so I think that's all from me. Thank you again for watching this video, and if you have any question, please put a comment in the YouTube comment section. And if you have, and if you have suggestion as well, you can put a comment. And if you feel that this recorded video is beneficial, please subscribe to this channel. Okay, thank you again, everyone. See you in the next video. Wassalamualaikum warahmatullahi wabarakatuh.